quadratic functions. F of x equaled 8x squared plus bx plus c is the general form of a quadratic function. This should be familiar to you because we've worked on quadratic equations, but we're going to concentrate on the graph of a quadratic function here. So this is the general form. We have another form that's actually more useful to draw the graph if we have it, and that is called standard form, which is below. It's a times x minus h squared plus k. And your a is not equal to 0 in these. This gives you a parabola, and the vertex of the parabola is going to be hk. Just like with our circles it was minus h and minus k. For the center of the circle, it's minus h, so watch out for that. But your k here is positive, so whatever sign is there. So just be a little careful of that. So we will get the vertex is hk. And just from our graphing of transformations, remember if the number in the front is negative, has a negative sign, then it's going to flip upside down. And that's exactly what happens here. If a is greater than 0, so if a is positive, the parabola is going to open up. So it's going to look like this. If it's negative, it's going to go upside down like that. So a negative a would cause it to turn upside down. We have another term with parabolas, and that is the axis of symmetry. This goes through the vertex. The parabola flips across it because parabolas are symmetric. So if you know the vertex, then the line of symmetry is x equals h. So your first coordinate of that vertex. So it will be that vertical line. And this one is an example with your a being positive, so it goes up. Here is your axis of symmetry. And here is one with a negative a. A is less than 0, goes down, and this is your axis of symmetry. Remember also, in chapter on functions, we talked about relative max and relative min. Well, with these functions, we're going to have a max and a min, and the lowest point on a parabola is your vertex, and this would be a minimum. And if it has the highest point, so if it's upside down, it's going to have a maximum. And you will again have to worry about where it is. That's the x-coordinate. The value of it will be the y-coordinate. We have a couple more pictures to look at. On this first picture, notice your parabola here that has the vertex of 0, 0. This one is your standard parabola, your y equals x squared. Or here it's y equals ax squared. If it was our standard one, the a would be 1. But the a could be anything here. And vertex 0, 0, so your axis of symmetry is x equals 0. This one, it just has a different vertex, so it slid over and it slid up. The vertex is hk. Its axis of symmetry will be x equals h. And these open up. Our a is positive. All right, for this next picture, this a is negative for it to open down. It's like negative something x squared, right? And if it's just the standard one, it would be, a would be 1. So it would be negative x squared would make it flip like this if it wasn't stretched. All right, and its vertex will be 0, 0. Its axis of symmetry is x equals 0. This one is just slid over. It slid over and up, and its vertex is hk. So it slid over h and up k. Its axis of symmetry will be x equals h. For our first example, we have a function that is in standard form, a parabola. Its a is 1, and it's positive, so it opens up. We can read off the vertex, and it is in the form x minus h. So we will have 2, negative 1 will be our vertex. Right. Our axis of symmetry will be x equals 2. Right. Our x-intercept, I'm going to come back to that one in a minute. It's easy to locate on this picture because we have the picture. It's going to be here and here, which looks like 1 and 3, but we will calculate those by letting y equals 0. The y-intercept lets x equal 0. So we'll go ahead and do that one. This gives us negative 2 squared minus 1, which will give us 4 minus 1 is 3. So this would be 0, 3. And we actually don't see that one on the picture. If they want an ordered pair, your x is 0 on a y-intercept. All right, I said I would come back to this one. The x-intercept, you have to let the y equal 0. And this is the one that can cause more work. So if we move the 1 to the other side, so we'll add the 1 to the other side, we have a quadratic equation that's set up nicely for the square root method. So if we take the square root of both sides, remember this will give us plus and minus. The square root of 1 equals x minus 2, and that will just take your exponent off. The square root of 1 is 1. And I'm going to have to add a 2. I'm going to have to keep going this way just a little bit. I'm so sorry. All right, so I have 2 plus and minus 1 equals x. So 2 plus 1 is 3. And 2 minus 1 is 1. And so we have 2 x-intercepts, which we picked off the picture, but you won't usually have the picture ahead of time. Our next problem is also a parabola. It is in the standard form, and our a is a positive 2 here, so it's going to open up. We can pick off our vertex. Now you have to be just a little bit careful here, because minus h is the form and you've got plus 1, so this is minus a negative 1. That's how you get plus. So it's going to be negative 1. And here, that's plus, so it just will take that sign. That will be our vertex. Axis of symmetry, x equals negative 1. We've already answered that it opens up. And if we want the y-intercept, we let x be 0. So this will just be a calculation. Remember to go with order of operations. 0 plus 1 is 1. And then we'll have to do the exponent. 1 squared is 1. 2 times 1 is 2 minus 3. This gives us negative 1. So 0, negative 1 if they ask for an ordered pair. Let's look at our next one. This one might not appear to you in this standard form, but it actually is. Our a is -1, and this we don't have the parentheses. What would the h have to be to not show up? 0. So here our h is 0, and let's go ahead and put our vertex. So we're going to have 0, and then this one will be whatever sign is there. So our vertex is going to be 0, 4. All right. Our A is -1 on this one. So it's going to open down. Our axis of symmetry is going to be x equals 0. So this one's going through the y-axis. For our x-intercept, we have to let y equal 0. So we're going to set this equal to 0. And if we move this x squared to the other side, it would have a positive coefficient. And we usually like that with solving quadratic equations. Right, and this is a perfect one for the square root method. So x is equal to plus or minus square root of 4, which is plus or minus 2. So we're going to have two x-intercepts at +2 and at -2. Right, for the y-intercept, let the x be 0. And so this is going to wipe out to just give us 4. So this will be 0, 4. If the quadratic is in general form, we could complete the square and put it in standard form, but that's a lot of work. It is easier to use this formula for the vertex. So you're going to use your coefficients a, b, and c. And so first your x-coordinate is -b over 2a. And then that answer you plug in to your formula to get the y-coordinate of your vertex. All right, for this one, we are in general form. And so let's do the vertex with the formula. So our a is 4. B equals 8, C equals 1. So we're going to do -8 over 2 times A, which is -8 over 8, which is -1. All right, this is the x-coordinate. We're going to plug this value in to find the y-coordinate of the vertex. So we do f of -1 so we have -1 squared will be 1 times 4 will give us 4 minus 8 plus 1. This is -4 plus 1 will give us -3. So our vertex is going to be -1, -3. This one, it opens up because our A is positive. Our axis of symmetry will be x equals -1. And our y-intercept, you plug 0 into x, and that's easy to do here. So 0 squared is 0 times anything is 0 plus 0 plus 1. So this gives us 1. So 0, 1 is our y-intercept. Now, where we're going with this is to be able to draw this picture of this parabola. You need to know first which way does it open. You need to know the vertex. Your axis of symmetry is going to be through that x coordinate of the vertex. And you need to know one more point. And then you will flip the picture across that axis of symmetry to get a second point, and you know it's a parabola. So this makes an easy way to graph. Let's take a minute and draw this graph now that we've found all the information we need. The first thing you really do need to know is which way it opens. And so because this A is positive, it's going to open up. Right? Then you need the vertex, which we found with the formula. So we have -1, -3. And we know it's going to go that way. All right. This is my axis of symmetry. All right. And 0, 1 is another point for us. So it is the y-intercept. So over 0, up 1. Now, this is the axis of symmetry. So it's going to flip across. So we will have another point right here. And we can draw the parabola. Let's look at one more of these. So we have the general form of a parabola, and let's get the information we need to draw the graph. So first of all, our A is negative, so it's going to open down. All right, we want to find the vertex. So we're going to use our formula for the vertex. -b over 2a. And then we'll plug that in. So -b, all right, b is already negative. So the opposite of that will be a +8 over 2 times -2. This gives us 8 over -4, which is -2. And now we're going to plug that into the function f of -2. And this gives us -2 times -2 squared minus 8 times -2 plus 7. Exponents go first. This gives us a +4. Then you can do your multiplications. So we get a -8. This will give us +16 plus 7. And so this would give us a +8 plus 7 is 15. So our vertex is -2, 15. Our axis of symmetry, I'm just going to call it axis x equals -2. So it flips across that line. And the y-intercept is the easy one to get. So you plug 0 in. When you plug 0 into this, it's going to wipe out this term and this term. So it's just going to give you 7. I'll write that, but you don't really have to write it when you get used to it, because it's going to wipe those out. So that gives us a point. And then we have enough information to draw the graph. This one is not going to be very nice, so I'm not going to graph it. And the reason is it's going to go off my grid. because of the vertex. What we can do is put it in our graphing calculator, right? And so if we're going to do that, we're just going to type in the whole regular function. And so we will turn it on. We'll go under y equals negative 2 x squared minus 8x plus 7, and we'll tell it to graph. All right, and see it's going off the grid. You can change that here though, and see that by changing your window. So I would like to see that, I would like to go higher on the y-axis. So if I go to my window, my x is okay. So I would like to my maximum y to go to 20. And I'll leave everything else the same. Now let's graph it. See, now I can see the vertex and that it opens down. And here is our axis of symmetry.